Hello class, and welcome to lesson 6.8, continuity correction. Today we take a look at how to address discrete data when it's normally distributed. Okay, before we get to that, let's do our warm-ups for 6.8. Remember our notation here that says x is a random variable that is normally distributed with a mean of 72 and a variance of 12 squared, which means the standard deviation equals 12. All right, so then it says to find the probability when the random variable x is between 70 or 80. I could apply this to my math class in terms of any math class I have and I have a test. Say I want to know what's the probability that on the next test you will get between 70 or 80, given that my class average is 72 and my standard deviation is 12. That's an easy way to change it to an application question. Now, first thing we have to remember, so when we've got this probability between two things, we have to take the probability of the upper, which is probability of being less than 80, okay, and we've got to subtract the probability when it's between, subtract the lower limit, okay. So if I had a lovely little diagram here, I would know that my median is 72. Again, if I could add 12, that would be 84. Okay, or subtract 12, that would be 60. Again, we want between 70 and 80, which is right here. We know that, again, you can't use the 66, 95, 99.7 rule. And when you know z-scores, folks, remember z-scores work for any value, if it's on the standard deviation boundary or not. So you may just wish to use z-scores. But I may ask you to explain the rule or whatever, so make sure you do know that rule. All right. So, because we know these aren't on our standard deviation boundaries, we know we're going to use z-scores. So let's just off in the side, let's use our z-scores. So let's find the first one. So z equals, or the high end limit. Okay, so it's going to be 80. Subtract 72 divided by 12. So that z-score is 0.67. Do the second one, which is your lower limit. It should be negative because it's below the class average. If I apply it to my word problem. All right, so just make sure that when you transfer these over that you put the higher limit with the proper z-score. I've seen people in the past do this and get those mixed up. Okay? All right, and now you would use your z-score sheet on 606, 607. Remember, I'm going to give you that sheet for your unit test and your final exam, so don't worry about memorizing it. Just make sure you know one side's positive and one side's negative. So looking these up, you should have 0.7486, subtract 0.4325. That equals 0.3161. Therefore, either 31.6%, or I would even accept 32% here. Okay? All right. So now we're going to take a look, folks, at what we call the continuity correction. Okay, and so we're going to solve problems involving normal distribution of discrete data. So discrete data is different. Remember, discrete data is something that is countable, not measured. So you could say, for example, number of people. Okay, you can have 20 people, you can have 10 people, but you can't have 12.5 per people. So there's no decimals or fractions. So because of that, we're going to do the continuity correction. All right, so what I would like you to do is I would like you to realize that we are going to approximate the distribution, okay, of a discrete random variable. It's not exact, but approximating is getting you pretty close. It's a pretty significant estimate. So first thing I'd like you to do, folks, is pause my video, go to this YouTube video link, and watch this. And it is British, and he'll say, pause and give it a go, and I think that's kind of funny, but that is interesting. Please watch that video. That'll give you a better understanding, and then come back and try the example. So pause the video now, Okay, welcome back. Hopefully you watched that video. If you haven't, make sure you do. Now we're going to get on to some of these lessons. So hopefully you have a better understanding of what the approximation looks like and what the graphs look like. Okay, because he went into detail in the video about what each bar looks like and how we account for each bar. Okay, so that was a great video, and I've known people to watch that video right before their final exam to help them remember this as well. Okay, so let's take a little example. In Canada, the number of household objects plugged in at any given time is normally distributed with an average of 12.6 and a standard deviation of 5.4. Well, we know, ladies and gentlemen, that you can't have 12.6 devices plugged in. It's either 12 or 13. However, when you do the mathematics, you get a decimal answer, right? Same with the standard deviation. Okay, so that means either you could have 5.4 appliances above or appliances below, or gadgets, or whatever they are, lights, whatever we're talking about. All right, so question A, what is the probability that the household has exactly 15 devices plugged in? So remember, when we look at this, folks, it's the number of household objects. As soon as you see the number of something, that tells you it is discrete. So you know you're going to have to take a look at doing the continuity correction. And in the video, he may have used CC for continuity correction. If not, I'm going to show you that short form when we go down below. All right, so we want to know what's the probability that they have exactly. So that means x equals 15. Okay, so what we have to do is we have to apply the continuity correction because even our mean and our standard deviation are not rounded to the nearest one. So remember how the bars went in the graph. So if we want to know exactly 15, which is right here, guys, okay, our graph would look something like this going up, okay, and because 15 is the middle of the box, okay, so halfway away from it, that would be 14.5, so half less, and then half more is 15.5, okay, and remember we wanted this whole area, okay, and remember that hopefully in the video they showed that this area that's missing should make up approximately for that area that is extra on top. So that's why we approximate, okay? All right, so the continuity correction tells us instead of doing probably equaling 15, that our probability has got to be when x is between 14.5 to 15.5, okay? All right, and then, ladies and gentlemen, we revert back to using our z-scores. So just do z-scores over in the side. Hopefully you have the z-scores formula memorized. If not, you know it's on your formula sheet. So let's do the upper limit first. Okay, actually, let's write this in first. So just to make sure we've got it. So in order to do an upper limit and lower limit, you always take the probability of the the upper limit, subtract the lower limit. Okay, now we'll go over and do our z-scores. So take the upper limit, which is 15.5, subtract the average, divide by the standard deviation. Hopefully this is an easy thing for you now since we've done it for a couple classes. Okay, now we do the lower limit, and it should be negative. Let me try that again. My brain's not functioning right now, so I'll get my pen to paper here. We'll get her figured out. There we go. Ever have days, guys, when you want to write something different, and then your brain says, that was one of those moments. All right, so you get the second z-score, and it was 0.35. So now we replace, instead of using x's, we're now going to use z-scores. I'm just going to move it over a bit more. Have enough room. So replace the appropriate one. Okay. And then use your charts to look them up. So 0.7054, subtract 0.6368. Okay. And that equals either 7% or 6.9%. I'll take either or. So therefore, approximately 7% probability that 15 devices are plugged in. And I would suggest, folks, that this data with the 15 devices, or sorry, with the average of 12.6 devices, this was pre kind of like cell phones, pre iPads and stuff. So I bet the values are a lot more now. Okay. All right. So hopefully you've got a good, I'll say a good go at that one, like the video says. Give it a go. All right. B part. What's the probability that a household? What's probably of a household having more than 7 items plugged in? So probability where X is greater than 7. Okay. And remember, if we take a look on our graph, we know 12 is the middle, so 7's down below somewhere. Okay. So if I do a bar of 7, kind of like that, and 7's right in the middle. Okay. Remember, we want to approximate to the left to the right, so the lower boundary is going to be 6.5. The upper boundary is going to be 7.5. Hopefully that video made sense. If not, go watch that video. Okay. And then we want to calculate that area. And again, although it's not exact, this part here should equal that part there. Okay, that we're missing. All right. Okay, so what do we have to take a look at? Okay, well, we need what side? I apologize. I drew this in incorrectly. So let me back this truck up. Sorry, live video. Let's see if this works. There we go. Okay, so we got the lower limit, the upper limit. I forgot to read it. It says greater than, more than. So it can't be in 7. So what we're actually looking for, folks, is this area here. More than. I didn't read my notes really well. Okay, so more than. Okay, so it can't be between 7 and 7.5, so that's why we go to the outer limits. So this equals the probability where X is greater than 7.5, and then you give me an arrow and say CC, which means the continuity correction. Okay. All right, so CC, continuity correction, not continuity, CON. There we go. All right, so once we know our limit, that is our lower limit in this case, so our lower limit is 7.5, so we're going to find the Z-score for that. So 7.5, subtract our average, divided by our standard deviation. Make sure it's negative, so negative 0.94. Okay. And when we go to plug this in, we got to take a look here at our sign. So our sign is currently greater than. That doesn't work for our chart. So we've got to go 1, subtract the probability of X being less than 7.5, because we do the opposite. So now we have a less than sign, which works with our Z-scores probability. Okay. So plugging that in, we now know it's 1 minus the probability of Z being less than negative 0.94. Use your chart to look that up, and you should have 0.1736. And then, ladies and gentlemen, don't forget to subtract that from 1, so you should have 0.8264. So, therefore, there is an 83% chance of households okay, so 83% of households will have more than 7 plugged in. I'd hate to guess how many I have in just one room alone. I know there's at least more than 7 right in my living room. Check yours out. How many do you have? Let me know. All right. Last example. Okay. Oh, boys. and girls. The number of puppies. I just got a new puppy named Maya, so I'm all excited about this. The number of puppies born on any spring day in Stratford is normally distributed with a mean of 16.1 and a standard deviation, that just means it's a sample, of 6.2. What's the probability that less than 10 puppies being born? Okay. Well, first of all, as soon as you see number of puppies, you know that's discrete. So that's your signal to remind yourself, hey, I got to use CC, which is continuity correction. Okay. So let's take a look here. So we want, what's the probability where X is less than 10? Because it says less than 10 puppies. Okay. So when we take a look at that, we can't, if we have 10, okay, 10's in the middle. Less than means we can't have anything in this bar, so it has to be what? 9.5 and less than. So it has to be that area. Okay? So to do our continuity correction, okay, that is that probability is X becomes less than 9.5. Good news is it's less than, ladies and gentlemen. Okay? So we are going to then use our Z-scores. So let's go Z equals 9.5, subtract 16.1, divided by the divided by the standard deviation. Plug that in, ladies and gentlemen, negative 1.06. So that equals the probability of Z being less than negative 1.06. Use your chart, and you'll get 0.1446. That equals about 14.5%. So what does that mean? So therefore, approximately 14.5% probability of less than 10 puppies being born. Okay? Awesome. Now, one thing you could do, folks, is again, you can use technology. So let's just quickly go over that. So use the TID3. Okay? And you could use your normal CDF. And make sure when you do your lower limit that we use -1 to the exponent 99. Okay? As your lower limit. Your upper limit is 9.5. Your mean is 16.1. And your standard deviation is 6.2. And we close that. And you get 0.1435, which is pretty darn close. Okay, so that gives you 14.4% versus 14.48. So it's pretty close. All right. All right, so your homework today, folks, is to create a study sheet for your last unit test. Oh boy, last unit test. How do you like that, guys? Last unit test. Okay, do you know what this means? This means this is my last official new lesson. All I have is the review for this unit and then the review for the exam, and we are done. Holy moly, this course is almost over. So get ready for your upcoming test. You will have practice questions. You'll have practice questions coming up, you have practice questions coming up on your review for your test. There will be a sheet ready for that. Okay, so continuity correction, you will check this here, and make sure you know how to use technology, guys. It can help you. If you need help doing this, let me know. And ladies and gentlemen, hope you have a great day. And I'm sorry to say this is my last new lesson. You guys are so upset. I know you're going to miss all my voice all this time. Anyway, I'm sorry, but I'm rambling. So I'm going to stop the video.